Hello there guys, welcome back to another video on simple random walks. This is the second video and we've got a very interesting question, and this is actually going to kind of underpin a lot of the stuff that comes up in the concept of simple random walks, stochastic processes and things like that. And that is this idea of splitting the problem into what you call disjoint blocks. And I'm going to talk about that in a second. First of all, let's just make sure we have defined all of our notation properly, and then I'm going to pose a question to you. So we're going to say that Sn is just the sum of n of these xi's here, and each xi is a random variable that will take the value 1 with probability p and -1 with probability q, which is the same thing as 1 minus p. Okay, the question is, what is the probability that at step 2a, so when n is 2a, the sum is 0, and when n is 2b, it's 0 again? Not necessarily for the second time. If a is quite a small number and b is a really big number, then we could have lots of zeros in between those two steps of 2a and 2b. But if I give you two numbers like 3 and 10, what I'm saying is, what is the probability that s sub 6 is equal to s sub 20, and they're both equal to 0 as well? What's the probability of that? We're going to look into it. The big problem, and the reason why this is quite difficult, is that those two things are not independent to each other, okay? So I'm going to just write this down, make sure that makes sense. So this is the same thing as the probability that S2A equals 0 and S2B equals 0. That's what we're asking. But this and this are not independent. You might remember that in the last video, we found the probability of this. This is actually a binomial situation of just what is the probability that after 2a or 2k steps where we have returned to 0. Not necessarily for the first time, but we have returned to 0. And we've worked it out and it was binomial. You might say, okay, well, don't you just times these two binomial situations together? But they're not independent. And that's because if you know that after 2a steps you are at 0, that is giving you information, and it's actually, you know, it's gonna affect what s sub 2b is doing. Because, for example, if s sub 2a was not 0, if it was 100 or something, somehow, right? If a was big enough, it was 100, then the probability that you're back at 0 at step 2b is a lot less than if s sub 2a is 0, like how we have in this question. And actually the probability that s sub 2b is 0 is a lot higher. So these two things are not independent. That's what I'm trying to get at. It's really, really, really important. So what do? Well, we split into what you call disjoint blocks. What does that mean? Well, it means that I'm going to split this probability into two events that are independent from each other. So I'm going to rewrite this as the probability that s sub 2a is equal to 0. And then this s sub 2b, what am I going to do about this? Well, I need s sub 2b and s sub 2a to be the same because they're both equal to 0. So what I can say is that I can also say the probability of 2a being 0 and s sub 2b minus s sub 2a being 0. Okay, and you'll see that that's the kind of trick basically. Hopefully we agree that what I've written down here is the same as what I've written up here, but s sub 2b minus s sub 2a, this is independent of s sub 2a. Okay, and just to emphasize this, remember all this means, okay, this first bit is the sum from I equals 1 to 2a of the xi's being 0, and then this bit here is the sum from I equals 1 to 2b of the xi's minus the sum from I equals 1 to 2a of the xi's equaling 0. And I can continue to simplify this, and I can write it as my probability of the sum from, again, I equals 1 to 2a of the xi's equaling 0. But more importantly, I can simplify this sum to just one big thing in sigma notation. So this one here is the sum from I equals, it's actually going to be 2a plus 1 up to 2b of the xi's. Okay, and just look at that and make sure you're super happy with that, right? I'm adding up all of the xi's from 1 to 2b. So that's x1, x2, all the way up to 2b. But then I'm taking away from 1 to 2a. So I'm left over with just the xi's starting at 2a plus 1 and then ending at 2b. But this is the thing. does it make sense now to say that these two things are independent, right? If I know the sum from I equals 1 to 2a, if I know that that's 0, it doesn't tell me a single thing about the sum from 2a plus 1 to 2b. Doesn't tell me anything. Whereas beforehand, it did. So up here, if I know the sum from 1 to 2a is 0, then I have some information about the sum from 1 to 2b because I already know the sum from 1 to 2a. So I know all of that. And then, of course, from, 2a plus 1 to 2b, I don't know that, but I know like the first, at least part of it. And if I write it like this, these two things are genuinely independent from each other. And what that means is we can use the result from my previous video, which I'm going to write down right now. So here it is. In the last video, we derived this formula, okay? So the probability that the sum from the first xi all the way up to the 2kth xi, they add together to make 0 is 2k choose k times p to the k times q to the k. Now, how do we get that? Because this is really important because we're going to need to do a slight modification to this for the second part, okay? First part, hopefully you can see, we can just plug in a equals k and we're fine. But this one, because we're not starting from I equals 1, we have to do something a little bit different. So what we've got to do here, and actually first I'm just going to explain this yellow formula because we did derive it in the first video, but I'm just going to explain it again as a refresher. Basically, what we realized is in order for this to occur, the number of total plus ones going up has to be the same as the number of total minus ones going back down. That's the only way that you can return to 0 in 2k steps. You need k ups and then k downs, not all in the same, not like up and then down. They could be like up down or whatever combination that you want, but you need k ups and k downs. If we treat this as a binomial situation, which it is, then the probability of going up is p. We already know that, so we could imagine this as a binomial thing. The probability of a success is p. The number of trials is 2k. And what we really want is the probability that if I just say y equals k, and this is like where y is binomially distributed, 2k trials, probability of success p, we're looking for this many successes because we need k successes and k failures. That's how it works. So that's how you derive, and then you just literally, of course, hopefully it's pretty clear to see that you're just going to end up with this. Nice. Now, what about, and actually let's write this in here. So we're going to go over here. The first part of this, because now again, these two things are both independent. The first part of this, the probability that the sum from I equals 1 to 2a of xi equals 0 is literally just this formula here, but instead of a k, it's an a. So it's 2a choose a times p to the a times q to the a, just like that. Now, the reason why I explain this yellow thing again is because now this is where we need it. We need to use the logic that I just explained, but we're not starting from 1 anymore. So if you start at 2a plus 1, and then you go to 2b, how many total steps actually is that? Remember, we're including 2a plus 1. Well, the number of total trials now is 2b minus 2a. Okay, I hope that makes sense. This is the number of trials. Basically, this is the number of xi's in this sum. There's 2b minus 2a xi's. Don't know whether they're pluses, minuses, or obviously, most likely some combination of both, but there are 2a terms in this sum. That's basically what I'm saying there. Again, the probability of a success, I'll say a success is going up, is once again p. So again, it's this many trials, probability of success p. And again, I'll just use y. So I'll say y has a binomial distribution with those parameters. And I'm literally just going to, I'm just going to delete this because this is a bit confusing now. But I'm literally just going to use the formula once again, the probability mass function of a binomial distribution. Again, we're timing them together because they are independent. So I'm just going to times this by number of trials, 2b minus 2a. How many successes do we need, guys, for this one? Again, we need half the successes as there are trials because we need to go we need half ups and then half downs, right? So we're looking for the probability that y equals half of 2b minus 2a, so just b minus a. So it's going to be 2b minus 2a choose b minus a, and then p to the power of, how many successes do we have? Well, we've got b minus a successes, and then how many failures? again, b minus a failures as well. Now we have this expression, and they are indeed multiplying together because they are two independent events. They're disjoint blocks, you could say. And we can do a slight bit of simplification here because you see p to the a, and there's a p to the minus a there, likewise with q. So we end up getting 2a choose a times 2 times b minus a choose b minus a, like this. And then we've got p to the b, q to the b. And if you want, you could rewrite this in one bracket, obviously. But this is our formula. So just to be clear on what we have done, because I think that's quite a lot, and it is actually it's quite conceptual. So if you don't understand this immediately, then it's okay. But what I would really strongly recommend is for you to try and do the question yourself after you've seen this. You might roll your eyes, but seriously, I think it would be really helpful to really embed it. But I'm just going to go through everything again. So if you've got it, you can just leave the video now. But I think you should stay and, let's finish it off. So we said Sn is the sum of n of these random variables, taking the values 1 and minus 1. The question is, what is the probability that after 2a steps, so the sum of the first 2a of these random variables equals 0, and the sum of the first 2b equals 0 as well, for some given a and b where b is bigger than a. We notice that basically this is just the probability that s sub 2a equals 0 and then s sub 2b equals 0. The issue is that those two things are not independent from each other, because s sub 2b, some of the terms in that are from s sub 2a, so they're not independent. So you can't individually work them out and times them together, because as everyone knows, if you're watching this video, you can't do that unless the two things are independent. So what you do is you separate it into two independent events. And this is an incredibly important concept that will be used again and again and again and again in these videos. So we split this into the sum of the first 2a terms is 0, and the difference between the sum of the first 2b terms and the sum of the first 2a terms is 0 as well, because that's the equivalent of up here. It's just rewriting it in a clever way. These two events are now independent, because s sub 2b minus s sub 2a equaling 0 has nothing to do with s sub 2a equaling 0. You can clearly see that when you write this back out in sigma notation, in summation notation. You simplify that second sum, and you realize that none of the xi's that were on the left appear in this condition on the right. None of them. So you do not have any information about the sum from 2a plus 1 to 2b. That's why they're independent. Then we recall what we did from the last video. If you didn't watch the last video, again, it doesn't matter. It's just binomial. First one, we're thinking, okay, well, how does this actually happen? How does the sum from I equals 1 to 2a of x, of all of these xi's, how does it equal 0? Well, we need k ups, or in this case, a ups and a downs. This can be modeled with a binomial situation. And it's 2a choose a times p to the a times q to the a. That's literally all there is to it. And then over here, we do the same thing, but of course it's slightly more complicated because it's not starting at 0. Important thing though, is that there are a total of 2b minus 2a steps or terms in this situation here, and a probability of success, which is going up in your random walk or stepping forward, is p. And we just want the probability that half of the terms do that, and then, by extension, the other half don't, they go down. And so we want the probability that, I've called it y, equals b minus a. And it's the same thing, it's just binomial again. So we times them together, and then we just simplify it, and that's the final answer right there. So incredibly important result, or is really, really useful to make sure you fully understand this, because again, this technique is going to be used again and again, and typically it's going to be used in harder questions. So make sure you really, really get this. But as always, guys, I really appreciate you watching. I know it's a bit of a longer one again, but I appreciate you guys sticking around. Thank you for watching, and I'll see you in the next one. Cheers.